Now, characteristic impedance Z0 equal to square root of R plus j omega L by G plus j omega C. So substitute R equal to G equal to 0, then Z0 equal to square root of L by C. So here Z0 is purely real for lossless line. Velocity of wave propagation V equal to omega by beta. So then omega by omega square root of LC. So velocity of wave propagation in the lossless line, that is equal to 1 by square root of LC. So that is equal to F into lambda. F is frequency, lambda is wavelength. So final conclusions in the lossless line, propagation constant is purely imaginary. So here propagation constant is purely imaginary, gamma equal to j omega square root of LC. Signal attenuation is equal to 0. So alpha equal to 0 in the lossless line. Phase constant is linearly dependent on frequency. So here beta equal to omega square root of LC. So beta phase constant is linearly dependent on frequency. Velocity of wave propagation is constant. V equal to 1 by square root of LC. So velocity of wave propagation is constant, independent on frequency. Characteristic impedance is purely real. Z0 equal to square root of L by C. It is purely real. So coming to distortionless line. So what is distortionless line? A distortionless line is one in which attenuation constant is frequency independent, while phase constant beta is linearly dependent on frequency. So condition for distortionless transmission line, that is R by L equal to G by C. So general equation for gamma, that is equal to square root of R plus j omega L into G plus j omega C. So gamma equal to square root of, take R and G both are common. So Rg into 1 plus j omega L by R into 1 plus j omega C by G. Square root of Rg into, so substitute transmission line, distortionless line condition here. So then square root of Rg into 1 plus j omega C by G. So then multiply with square root of Rg, square root of Rg plus j omega C by G into square root of Rg. So here R by G equal to L by C. So gamma equal to square root of Rg plus j omega square root of Lc. So here compare real and imaginary part. So real part alpha equal to square root of Rg, beta equal to omega square root of Lc. So coming to characteristic impedance, Z0 equal to square root of R plus j omega L by G plus j omega C. So here take R and G common in the numerator and denominator. Square root of R into 1 plus j omega L by R by G into 1 plus j omega C by G. So then Z0 equal to square root of R by G, that is equal to square root of L by C. So here Z0 characteristic impedance is purely real. So velocity of wave propagation U equal to omega by beta, that is equal to 1 by square root of LC. So final conclusions for distortionless transmission line. First one is attenuation does not dependent on frequency and it is constant. So here alpha not equal to 0 and it is constant, independent on frequency. Alpha equal to square root of Rg. Phase constant beta equal to omega square root of Lc. Phase constant is linearly dependent on frequency. Phase velocity, that is equal to 1 by square root of Lc. It is dependent on frequency. Velocity and characteristic impedance remain same for lossless lines. So velocity and phase constant, these two equations are same for both lossless line and distortionless transmission line. A lossless line is a distortionless line, but a distortionless transmission line is not necessarily lossless. So here lossless transmission lines are desirable in power transmission, whereas telephone lines are required to be distortionless.